Okay, guys, I'm off to cross country state. Go Landon, go Zoe. I'll be there to cheer you on. You guys are awesome. So, if you had done the exercise, the reading exercise from your phone, you should get these values. And of course, Celeste, you may use my iPad, of course. So you just took these values from the unit circle, and what turns out, this is about a 0.7 approximately. It's about 0.7 approximately. It's about a negative 0.7 approximately. And this is another negative 0.7 approximately. Okay, and the same thing with the cosine. This is a 0.7 approximately. This is a negative 0.7 approximately. It's approximately negative 0.7, and this is approximately a positive 0.7. Okay, those values are going to help us make a cosine and a sine wave or a curve. Okay, so if I take those values, and you have your reading in front of you, okay, what I'm going to do is do a dot to dot with those values. Now these values come from the circle, so in a sense we're going to unwind the circle, and it should have a nice wavy look to it. Okay, so I'm going to add a few things. I'm going to add pi force. I'm going to add 5 pi force. I'm going to add, 3 pi force. I'm going to add 5 pi force here and 7 pi force here. And I'm even going to go backwards and go negative pi force here. Okay? So I had all my pi force. The reason I wanted to add my pi force is it's going to help me get these values in my circle. So, how does a sine wave look? Well, it comes right from the unit circle and all the sine values. Remember, the sine values are the y values. So each angle, these are my angles, theta, are going to have corresponding sine or y values. So sine of 0 is 0. Sine of pi force is square root of 2 over 2, which is about 0.7. So we'll put a dot there. Sine of pi halves is 1. Sine of 3 pi force is a square root of 2 over 2, or about 0.7. So I'll put it out there. Sine of pi is 0. Sine of 5 pi force a negative square root of 2 over 2, so it's about there, negative 0.7. Sine of negative 3 pi halves is a negative 1. Sine of 7 pi force is negative square root of 2 over 2, which is about a negative 0.7, about there. And sine of 2 pi is 0. So you can pause the video anytime you want, but the curve looks something like this. It's a wave. It's called a sine wave or the sine graph. Okay. Now, it has a height called its amplitude. The amplitude is its height. It is 1. It goes up to a height of 1 and down to negative 1. It's kind of like a wave on an ocean. The height would be 1, and this would be like sea level. Okay. Cosine looks like very much like the sine, except for it's the x value. So I'm going to do the same thing on my cosine curve. So I'm going to add my force, because I want my force, so pi force, 3 pi force, 5 pi force, 7 pi force, and I'll add a negative pi force here, okay? Okay, and now I'm going to take the cosine values, which we got from our reading. Hopefully you guys have that. We're going to take our cosine values from the unit circle and do a dot to dot. Now the cosine values are the x values from the unit circle, okay? So, yeah, Ethan? Okay. Interrupted this, okay. So at 0, cosine's 1. Has a height of 1. Make sure I put the 1 up here. 1 and negative 1. So we'll put a dot there. Pi force for cosine is square root of 2 over 2, so it's about 0.7. Pi halves for cosine is 0. 3 pi force is a negative square root of 2 over 2, which is about a negative 0.7. Cosine of pi is negative 1. Cosine of 5 pi force is a negative square root of 2 over 2, which is about negative 0.7. Cosine of 3 pi halves is 0. Cosine of 7 pi force is a positive square root of 2 over 2, which is about 0.7. And cosine of 2 pi is all the way up to 1. Okay, so if we draw in the curve, it looks almost identical to the sine curve. Okay, I get its amplitude goes up to 1 and down to 1. Its height is 1. And there's one other thing we talk about, and that is the period. How wide? So let's talk about the period of both these graphs, okay? And again, if I'm going too fast, please just pause it. Ask the substitute, ask Mr. L to pause it, to pause it, and I'll get back. Okay, so the thing called the period is how wide. How wide is one full curve? All the way from going all the way up, all the way down, and back to the start. So the period is 2 pi, or one full revolution around the circle. That makes sense. So the width of this curve is 2 pi. The period of cosine is also 2 pi, because it starts up at 1, goes down, becomes negative at pi, comes back up, and then finally finishes back up at 1. So the period of this graph is also 2 pi. So what is the period of these two functions? 2 pi. And what is the amplitude of these two functions? It is 1. Now, the curve, if it's a wave, goes on and on and on and on. So what we could do is just extend the curve on both these and keep it going on and on forever and on forever and ever and ever. The same thing with this one. We can just extend it and go on forever and ever and ever, and so forth and so on. So I extended it. But one full curve looks like this, and one full curve looks like this, and then it's periodic because it continues to repeat that pattern. It's called a periodic function. Okay? Now, go ahead and pause the video, and we're going to look at your notes. Okay? Mr. L is going to pass out your notes. Pause the video. Let's take a look at the notes. All right. I assume I'm back, and I assume you guys have the notes. So, objective. What we want to do today is talk about graphing y equals a sine of bx, and we're going to graph y equals a cosine of bx. Okay? 11, 8, 19. Okay? So the amplitude is really like the height, but it's like the average of the height. Okay? So one way to do the amplitude is it's always going to be the maximum value minus the minimum value divided by 2. Okay? And it's always an absolute value because the amplitude is always a positive number. Okay? So the amplitude in this was up 1, 1 minus a 1. So the amplitude would be 1 minus a minus 1 would be 2 divided by 2 is 1. But we know it's up 1, down 1. The amplitude is 1. Okay? Now the period. The period is always going to be the value of b. Okay? And the period is how wide. So the period is how wide is the curve. Okay? If it's a standard curve, the period is always going to be 2 pi. If it's standard, it's going to be 2 pi. We learned that already. Standard period is 2 pi for both of these. Okay? But sometimes we'll squish it and stretch it. So that's called the frequency. So the frequency is how many curves in 2 pi. So the frequency is how many. The period is how wide, and the frequency is how many curves in the standard period. Okay? So example 1. Let's take a look at graphing it. So before I do anything, got to remember what the sine curve looks like. So the sine curve looks like this. When I take a look at the sine curve, there are 5 points that are really important. The 5 points are going to be its beginning, its end, its middle, its maximum, the top of the curve, and its minimum at the bottom of the curve. So what I do is I break my curve into 4 sections. I've got my first part of my curve to the max, second part of the curve is the middle, third part of the curve is down to the min, and the fourth part. Okay? So when I do these graphs, I'm going to make sure I break it up into 4 using 4 bars. 1, 2, 3, 4. Let's call that pi halves. 1, 2, 3, 4. That's pi. 1, 2, 3, 4. That's going to be a 3 pi halves. 1, 2, 3, 4, there's 2 pi. And I like to go 4, and you're going to see why in a little bit why I like 4, okay? All right, now, the amplitude of this one is 3. So I know it's going to have a height of 3. So the amplitude is 3. So I'm going to go up 1, 2, 3. It's also going to go down 1, 2, 3 to negative 3, okay? All right. I know the sine curve looks like this. It's going to have a height of 3. It's going to go up to 3 and down to 3, except it has a frequency of 2. So it has a frequency of 2. So that means I'm going to have 2 curves in 2 pi. So I'm going to have 2 curves in 2 pi, okay? So I want this shape here within its 2 pi, okay? So I want 2 of these curves, okay? Now watch. I want to have 1, 2. I need 2 curves within 2 pi because the frequency is 2. So the way you find the new period is you take 2 pi and you divide it by your frequency. I'm going to divide it by this value here. We call it b. So if I divide 2 pi by 2, the new period is pi. That makes sense to me because I'll have 1 in pi, I'll have another in pi, and I'll get 2 curves. Okay, so here's what I got to do. I'm going to take this shape and put it between 0 and pi. So I'm going to go, and it's going to look like this. Sine starts at 0. It ends at a height of 0, so I'm going to end it right here at pi so I can get it within the 0 to pi so I can get 2 of them in. Halfway through, it's going to be at 0. It's going to be up here at 3. It's going to be down here at negative 3, okay? So I'm going to get 1 curve in. And I'm going to do the same thing to get 2 curves in. I will repeat this pattern. Sine starts at 0. It ends at 0. Halfway through, it's at 0. Here, a fourth of the way, it's going to be up at 3. Here at 3/4 of the way, it's going to be down at negative 3. And there is my curve. Has an amplitude of 3, has a frequency 2 because it's got 1, 2 curves, so therefore the period, the new period is pi. Alright? Hopefully you're getting this a little bit. Okay, moving on. Okay, number 2. Well, it's a cosine curve. So it's this shape. It's negative, so it's going to be upside down. So let's see, it's going to be, let's see, so it's really going to be look something like this because of the negative. I know it's going to have an amplitude of 2. So the amplitude is 2, not negative 2, positive 2, because it's the absolute value of it. Okay? And then I'm going to have this shape, but I need 3 of them. So what I'm going to do is break my graph into thirds. Well, okay, if I graph it into thirds, I'm going to go take and make this 2 pi thirds, 4 pi thirds, and then 6 pi thirds or 2 pi. Okay, and I could have stretched this out a little further, but I didn't make my graph paper long enough. That's okay, it's going to work. So I want this shape right in here. So I can have 1, 2, 3 of them. So my frequency is 3. And then I need this shape to go 1, 2, 3 of these. Okay, I can do that. I just have to put that shape down. So it's going to look like this. Cosine. This one's going to start down at 2. And it's going to end at 2 pi thirds. Halfway through, it's going to be all the way to the top of 2. 1/4 of the way it goes through the graph, and 3/4 of the way it goes through the graph. So here's my first cosine curve. It's upside down, has an amplitude of 2. Now I'm going to repeat that 1, 2, 3 times, so I have a frequency of 3. Okay, so this pattern is going to repeat, starts down, ends down, halfway through it's going to be up, it's going to go through here and here. I'll do that again. Do that graph one more time. Starts down, ends down, halfway through it's up at 2, goes through here, goes there and there. Okay, now I have 1, 2, 3 cosine curves. The period is how wide this period is, 2 pi thirds. Because the way you get the new period is you divide, to get the new period, you always take 2 pi and divide it by your frequency. My frequency is this number here, 3. There's my new period. Okay, and again, if you need to pause this, go ahead. I'll be back Tuesday, because we all have Monday off, and we'll look at this again. But let me turn the page now, okay? Hopefully I'm not going too fast, but I am. Have Mr. L pause, okay? All right, now, sine of y equals 4 sine of 1/2. Now this 1/2 is weird because that means the frequency is 1/2. Okay, so it's like this. I'm going to have half a curve. Check it out. That's half a curve. I'm going to have half a curve between 0 and 2 pi. So if I'm going to have half a curve between 0 and 2 pi, that means I'm going to have a full curve within 0 to 4 pi. Okay, so I'll show you how this works. I'm going to have half a curve. Okay, half curve. Let's see. Let's make this for right now pi. Let's make that pi. Let's make this 2 pi, 3 pi, and 4 pi. Trust me on this, okay? Because I have to get half a curve here, and then the other half a curve here, okay? So, amplitude is 4, 1, 2, 3, 4, okay? Negative 4, 1, 2, 3, 4. Okay, let's see if I can explain this really well, okay? So, what I'm going to do is this. I'm going to take, and my new period is always 2 pi divided by my frequency, okay? So I'm going to figure out how big each curve is. So take 2 pi divided by my frequency, which is 1/2. So to find your new period, take 2 pi, always 2 pi, divided by your frequency, okay? So I know that's the same thing as 2 pi times, if I invert and multiply, 2 over 1, which makes 4 pi. So I'm going to have a sine curve. I'm going to have this sine curve here between 0 and 4 pi, because I've got to get it all the way over to here. Okay, so now my sine curve is going to look like this. Sine. Okay, a real rough sketch of sine. Sine looks like this. There's a real rough sketch of it. Let's make it look nice. Sine starts at 0. It ends at 0, but all the way at 4 pi. Halfway is 2 pi. 1/4 of the way it's going to be up at pi. And 3/4 of the way it's going to be down at 3 pi, okay? So let's see what I get. I have half a curve between 0 and 2 pi. That's my frequency. Yes, I have half a curve. That way a full curve has to go 0 to 4 pi. I have an amplitude of 4. Okay, amplitude of 4, okay? Hopefully I'm making a little bit of sense, okay? Because amplitude 4 is a little weird. I'm going to have 3.14 curves and 2 pi. That's weird. So let's take a look. So I told you we're always going to go 2 pi divided by the frequency. So the new period. Let's figure out what it is. Always 2 pi divided by my frequency, which is pi. Well, in this case, the pi's cancel, and I get 2. Now, knowing that, I'm not going to go pi or pi halves. I'm going to go by regular whole numbers, because my graph now has to have whole numbers. Okay, so I'm going to go like this. I'm going to go 1, 2, 3, 4. And I'm going to take my cosine curve, which looks like this. I'm going to take this shape and put it between 0 and 2, because that's my new period. Okay. All right. Amplitude of 1/2. So I might go by ones. I might call this 1. Stretch it out. I might make this -1, and that way my 1/2 is right here. I'm just changing my scales. I could do that, right? And then I need this shape between 0 and 2, because that's my new period. All right, so it's going to look like this. Starts at 1/2. It's going to end at 1/2, but at 2, because that's my new period. At 1, we're going to be down here at -1. Halfway through, halfway through. So one cosine curve looks like this. We've got one of them. Okay. Now, let's do another. 2 to 4. So end here, there, and there. Okay. Cosine starts at 1/2 ends at 1/2. Halfway through, it's going to be down here. So the curve looks like this. Now, what I have is really, in a sense, if I went all the way out to, let's see, 4, 5, 6, because 2 pi is right about here. 2 pi is right about here, which is 6.14. So if I kept drawing this, I would have, I'm going to keep drawing this for a little bit for you real quick. I would have, in a sense, 1, 2, 3.14 curves. I'd have 1, 2, 3.14 curves in the 2 pi, okay? All right, last but not least, let's do it backwards. Well, this looks like it's a sine curve to me, but the sine curve has just been moved up. Looks like it's been moved up. So it looks like it's been a vertical translation of 1, 2, 3, 4, 5. So the whole thing's been moved up 5. It looks like a sine curve to me. General shape of one curve is from here to here. Okay, there's one full sine curve. Hopefully you guys can see this. I can't really zoom it in anymore because I'm recording. So let's start there. I know it's going to be some y equals a sine of some bx, and then I'm going to say plus 5 because I'll take the whole thing up 5. Okay, whole graph's been shifted up 5. That's an easy vertical translation. Okay, now the amplitude. Let's see. The amplitude, this goes by 1, 2, 3. That's a 3, 4, 5, 6, 7. Looks like the amplitude is 2, right? It goes up 2, down 2. But if I'm not sure, we actually have a formula. Amplitude is equal to the max minus the min divided by 2. Amplitude is 4 over 2, which is 2. Okay, I kind of knew it was 2 because it goes up 2, down 2. So here's my equation so far. Y equals my 2 sine of bx plus 5. Now, what I need to do is find my frequency. Okay? So to find the frequency, we're going to do the opposite of what we do for the period. Okay? So first of all, let's find out how wide this curve really is. We're going to go from here to here. Okay? So we're going to go pi fourths, pi halves, 3 pi fourths, pi. Okay? So I'm going to have one curve within pi. Now remember, we can find 2 pi divided by the frequency gives me the period, right? Gives me the period. So then the frequency is just 2 pi divided by the period, or how wide it is. Well, that's easy. In this case, it's just 2 pi divided by pi, which makes it 2. I kind of knew that because from here to here is pi is one curve. I'd have another, so I know b has to be 2. So my equation, grand equation, y equals 2 sine of 2x plus 5. And hopefully you are not confused, but I want you to work on this, and I'll be back to help you guys out on Tuesday. Okay, so do the homework. Do the best you can, okay?